Okay, good afternoon. Good to be here together with you. The topic of today is signals, Angular and signals. Let me quickly double check if everything is fine. Yeah, looks like this. So let's get started. I have prepared several things for you today. I will start with an overview of the motivation and the basics of signals because signals are this new building block for reactive Angular, and it will change a lot in the future. And so I want to show you what's the motivation behind it and how to use it. Then we will move over to a demonstration. I will do a lot of live coding today to showcase how signals feel, how we can use them. Signals are a bit like the 1980s. You need to experience them in order to know what they are about. That's why we do a lot of live coding here. Then we will also talk about RxJS and NGRX, and we will see how those existing technologies will work together with signals. And last but not least, there is an outlook to the so-called signal components, a new component style for future versions of Angular, a new component style that will fully embrace signals. Let's get started with the motivation and the basics. So if we think about the change detection in Angular as it works nowadays, everything starts with Zone.js kicking in. Zone.js is monkey batching all your browser objects. All the objects there in your browser, like the promise or all the HTML elements like button or input or drop-down field and so on and so forth. It also monkey batches set timeout and set interval. And it really does this on purpose. It does this to find out when event handler run. Because after event handler run, Zone.js is notifying Angular. And now Angular knows, well, I need to activate the change detection. Now I need to check my components for changes. Because in theory, each and every event handler can change each and every bound data, bound item, in theory. In practice, we don't know that precisely, and so by default, Angular is checking all the components. However, if we switch on the on-push mode, which is the more performance change detection mode for Angular, Angular tries to select some components that might have been changed. It is capable of ruling out components that cannot have been changed. This kind of change detection brings some drawbacks. One drawback is Zone.js is kind of magic, isn't it? Monkey batching all the browser objects, changing all the browser objects is kind of magic. It's somewhere on the borderline between magic and very smart. I'm not sure on which side we are. It's somewhere in the borderline, but yeah. It works quite well until it stops working, and when it stops working, we really have a bad time debugging it. Another thing is Zone.js has about 100K, which is not a big deal for an enterprise application. However, if we talk about a web component, a little tiny web component you want to ship alone, then shipping this, let's say, 10K web component alongside 100K Zone.js does not feel right. And it's getting a bit more special if you need to go with several web components that need different versions of Zone.js. Another thing is that Zone.js can monkey batch all the browser objects, but it cannot monkey batch async and await, because async and await are statements. You cannot monkey batch statements. And for this very reason, async and await is still down leveled. It's still transpiled down to promise chains. Even though all the browsers that Angular supports nowadays also support async and await natively, we need to down-level those statements to promises. For this, we have some special code in the Angular CLI. And last but not least, change detection as it works nowadays is quite coarse-grained. With coarse-grained, I mean that at least one component is checked. On push mode, the affected component is checked plus all the parent components. We need to mark the whole path to the root component as dirty because the change detection Angular always goes top-down. And so it needs to find its way through all the marked components, all the components marked as dirty, to the component that actually has been changed. This is rather coarse-grained, at least for nowadays frameworks. Modern frameworks are quite more or a lot more fine-grained. They allow us to update a little tiny portion of the component. So let's say a little tiny data binding in the bottom right corner is changing, then newer frameworks are capable of just updating this little tiny portion. So the big question is, how do other frameworks solve all those issues? How do they compensate for those drawbacks? And as it turns out, all the new frameworks like Solid or Quick, but also frameworks that have been around for quite a time, like Svelte, are going with signals. A very simple reactive building block informing us about changes. And also existing frameworks are moving towards signals. Vue, for instance, is also moving in this direction. And so does Angular. So what is a signal? Well, a signal is just an object that holds a value. And this object can be read by a consumer. We can set it, and now the interesting thing comes, when we set it, we can notify our consumers. That means we have something like publish, subscribe, not in an event-based manner, but in a manner that allows us to find out when a value has been changed. And this is obviously interesting for change detection, also for other kinds of reactive systems, as we will see later. So I think in order to show how signals work, it's the best to compare a traditional application that is not using signals with a signal-based one. Here I'm starting with a traditional application. I have something like a property that is of the type of an ordinary class or interface. Here it is a flight array. I set this value, and I data bind this value here within a for loop. Straightforward. If we went with signals, it would look like quite similar. However, in the case of signals, we would need to wrap everything we want to data bind into a signal. And for this, we could go with this signal helper function. It takes the value we want to wrap. It takes the data type like flight array. Most of the times you don't need to pass in this type parameter because most of the time signal can infer the type from the default value. However, in the case of an empty array, it cannot infer the type of the array because here those brackets don't tell us that we mean to or that we plan to manage flights in here. It could be literally everything. So in this case, we need this type parameter. Then we can use the setter to update the value of a signal. Plus, when we want to read the value of the signal, we need to go with the getter. The setter here is an explicit method. The getter is just the signal itself used as a function. We are just calling the signal as a function. This works within the template, but also within your source code. Interestingly, when we read a signal in the template, Angular subscribes to the signal. And so Angular can find out when the signal is changed, and so change detection can kick in. Let me show you all of this in action. In this demonstration, I don't have YouTube, no. I have this here. I have my flight application that allows me to search for flights. For instance, flights going from Paris to London. And I can delay the first flight. It's the feature I've implemented for the union to increase the pressure a bit when they discuss about the money they want to have. If we look into the source code of all of this, then we see a traditional flight search component. We have traditional properties with default values, and those default values are data bound. And now let's try to migrate all of this to signals. For this, let's go with the signal wrapper, signal function here. Signal really is a part of Angular. It is part of Angular core. So let's import it from here. And let's also import that signal. When it comes to the flight array, as mentioned before, I need the type parameter because brackets does not tell that much about the type. And then within search, this is the method that is starting searching flights. We need to read the values from the signals, and so we need parentheses. Here we need the same. Okay, cool. If we want to set the signal, let's just call the setter. And here I have an interesting situation. Here I want to update one of my flights. This is the feature for the union that is updating the date of the first flight. The thing is, just updating the signal does not work because the signal itself is not the value. The signal is just a wrapper for the value. For this very reason, we need to unwrap the signal. And then we can do our thing that we can say, well, now let's work with the unwrapped signal. And at the end of the day, somehow we need to tell our flight signal that the first flight is changed. For this, we have several possibilities. We could change the whole flight array and then set the flight array again. That's one possibility. Another possibility is we could go with the mutate function. The mutate function takes the contents of the signal, which is my flights array, and in there we could mutate it. Here I'm grabbing the first flight and I'm setting the date to my updated date. In this case, we are going with mutables. If you wanted to go with immutables, then you could go with the update function. The update function at first glance looks similar to the mutate function. However, the big difference is it takes the current value and it returns a new value, the value that shall be used as a replacement. So this here will not change a lot, obviously. However, we could now create a changed array where we spread in the former array, everything beginning with index position 1, because we want to update the flight at index position 0. Everything is cloned, Everything? No, not everything, because the date is reluctant. Instead of the former date, we go with this date here, date to isostring. Okay. Yeah, it's a bit wordy. It's a bit more wordy. However, this allows us to nicely work with immutables. So for the time being, let's stick with mutables. I will switch to immutables in some minutes. Okay, cool. So in here, everything has been updated to signals. But this is also one side, only one side of the coin. We also need to update the template. And here the bad message is, so far the form support has not been updated for signals. Two-way data binding, the banana in a box syntax, currently does not work with them. The Angular team is aware of this, and they will modify the forms module in the future. Modify, reinvent, as you want to call it. However, so far, there is no out-of-the-box support for signals. But this is not a big showstopper, because we can always do two-way data binding in a more explicit way. Some people even prefer this explicit way. We could say, well, let's data bind from to this input. And when something changes, then please, let's write back the new value that is within this $event variable, pseudo variable, to from. So no banana in a box. Instead, we are going with an explicit property binding and an explicit event binding. Let's repeat this for the next field, dealing with 2. And one more time. And one more time, when reading from or to, we need the parentheses. Okay, cool. Let's go down. Also, flights is now a signal. So also let's use the parentheses here, and that's it. The loop will iterate over all the flights that are part of our signal. And if the signal is changing, the signal will notify Angular. That should be it. So let's check if everything still works. No, that does not look good. Oh, a lot of red characters. What's going on here? Let's restart all of this again. Let's cross fingers. Yeah, everything is green. That means we can already sell it. And yeah, when I'm clicking here on search, we see, well, it works. It still works. And perhaps you might say now, well, Manfred was explaining all of this now for about 15 minutes, and the application is still doing the same as it did before. So where is the value in here? Well, one value is that we now have a reactive system, and that means we can improve our performance. We can put on push to get a better performance. And another advantage is, because of having a reactive system, we can immediately react upon changes in our system. For instance, we don't need the user to click on the search button. We can immediately react when the user is typing something into those boxes. Perhaps let's start first with looking into change detection. Let's activate the on-push change detection that brings a lot of performance. To demonstrate the usage of on-push, I'm switching to my flight card component, and in there I'm doing something that is really dirty. I'm calling a method, a blink method. Normally, you don't call a method in your template. because if the method is doing something that takes a bit longer, this will slow down the whole change detection. Because obviously Angular needs to call this method time and again to find out if the data binding needs to be updated. However, here I'm doing this on purpose because I want to find out when Angular is updating my component, when Angular is running the change detection for this very component. Blink is doing what the name suggests. It makes the component blink. So we can really see when and how often change detection kicks in. Well, when we talk about not data binding methods, of course, you can data bind getters and setters, and you can always data bind stuff that is quite quick. Quick like calling a signal. Calling a signal does not bring a lot of effort. It's just about taking the current value and making sure we are notified when something changes. So this is not a big deal here. Okay, cool. Let's have a look how this blink function works. We already see it here. Every time change detection kicks in, our components will blink. And obviously, when downloading new data from the backend, everything is blinking because everything needs to be data bound. However, interestingly, when I'm starting to type in here something, everything is still blinking. Everything is blinking, even though none of those components have been changed. Well, Angular is doing this by default to be on the safe side. Because as mentioned before, in theory, each and every event handler could change all the bound data. Obviously, it won't change all the bound data all the times, but to be on the safe side, Angular by default is checking everything. It is a bit more weird when I'm clicking here to delay first flight. As you see here, it is just delaying the first flight. Then 33 to then 48 to 11.3 to 11.18. All the other dates stay the same. There is no change. However, Angular checks them because it does not know better in default mode. And to compensate for this behavior, we have the on-push mode. When we go with on-push, Angular really tries to find out which of the components could have been changed. It tries to rule out all the other components where we won't find a change for sure. And to activate on-push, we don't need to do much. We just need to set change detection to change detection strategy on-push. And then we need to make sure that we import change detection strategy from the right namespace. You know, when in doubt, always do the right thing, and the right thing would be Angular core. So let's do it here with in-flight card. And also, let's do it here with in-flight search. Let's search for flights. Everything is blinking. This makes sense because we need to initially data bind everything we got from the backend. However, when I'm now updating here something like my first flight, we see that nothing works. Nothing works. Somehow it's broken, isn't it? However, now it's fast. So we could tell our customers, well, you have to decide. It can be fast or it can be working. Choose your side. No, of course not. Of course not. We want to have both. We want to have a fast working application. Now, let's try to find out why it stopped working. Well, the thing is, in on-push mode, Angular, first and foremost in our example, will just wait until it is notified by a change. Traditionally, we notified Angular by using, let's say, an observable, let's call it $0, that was data bound using the async byte. And now almost the same works with signals. So this signal will tell Angular, hey, I've been changed, please trigger change detection. However, this is only one side of the coin. Knowing that this component might have changed is only one side of the coin. The other side is about finding out which of the child components have been changed. The first child component, the second child component, all the child components, or none of them. Angular somehow needs to find out. And for this very reason, traditionally, we went with immutables. Because if all the flights here are immutable, we just have to look at the object reference of the flight. If just one property of the flight is changing, the whole object reference is a new one. The whole object reference is exchanged. And this is what Angular is still doing. It checks if one of the past data items have a new object reference. Doing a deep comparison, checking all the properties, would be far too expensive. That's why they just go with the object reference. In the world of signals, there might be another option to tell Angular which of the child components have been changed. You could go with nested signals, something that is quite unusual. I would say it's an anti-pattern. It's even an anti-pattern in the world of observables. However, it's really fine and okay in the world of signals. You might want to nest the signals to notify several parts of your application about changes in several parts of your data structures. Here I want to stick with the more traditional approach. I want to stick with immutables. And as mentioned before, and calling mutate, I think the name itself already gives us a hint, we don't work with immutables. And just changing the date property does not help because Angular does not do a deep comparison. So let's comment this out and let's switch to using the update methods that now really mutates. No, that really works with immutables. That means we get a new array. The array gets a new first flight, and everything else is just taken from the old array. That means here for the first flight, the object reference is changing. Here for the remaining flights, it isn't. Okay, let's check if this works. Search, delay, and hey, it worked. How cool is that? I think this example really nicely shows how powerful on-bush is. On-bush, in this case, in combination with signals. We can really narrow down the amount of possible components to the components that very likely have been changed. How cool is that? Okay, this is one of the advantages. We have a reactive system, hence we can improve change detection. We can speed it up. The second advantage is because of having a reactive system, we can directly react upon changes. For instance, I could tinker a calculated signal that is called flight route. For this, we have this computed function. Also one of the building blocks signal ship with. It's also in here in Angular core. Computed. It takes a lambda expression. It also could be a method or a function, does not matter. Here it is a lambda expression. And then it's obviously computing something like my route. So the interesting thing about this is that computed will now execute this function, this lambda expression once. This delivers the initial value for the flight route. And then every time something changes in here, like from or to, the result will be recomputed. Compute will re-evaluate this expression. It will call this function again. And so we get immediately the updated value. So let's try this out. Let's data bind the flight route. I'm very sorry. I'm misusing the H3 deck here. I know it's not the fine English way of doing things, but I think it's good enough to show what compute is doing. Everything one of those things is changing, the computed value is immediately updated. Immediately. Yeah. Let's say it under parentheses because, you know, the real implementation underneath the hoods is a bit more complex. It's not the same stack frame, but that's not that important for now. I will come back to that in 1 or 2 minutes. Okay, cool. By the way, if you don't want to react upon the change of a given signal, you can use it together with the untracked function. So let's say 2 is not of our interest, and let's wrap it to untracked. And now we see the flight route is updating when we update from, but not when we update to. However, if we update from again, the current values are taken. So one more time, I say Paris change. I say London change. Nothing happens. London is still London 11111. But when I'm updating Paris, then yeah, I'm getting the current values of everything. It's a bit like the difference of combine latest and with latest from in RxJS, if you ask me. Okay, so much for untracked. I'm keeping this in here so it's documented for you, but for the time being, let's go without it. Okay, cool. So another way to react upon changes is to go with a so-called effect. An effect is modeling an side effect. For this, we should set up a constructor. At least the effect needs to be set up in an injection context, which is the constructor most of the times, or the default value of a property, for instance. And in here, let's call effect. That's it. Import it. And now let's say, well, every time something changes, we want to call search. What is effect doing now? Well, it looks into its lambda expression, into this function here, and into all the functions that have been called by this function, at least at a logical level. It's that way. And then it subscribes to all the signals that are read here. And when one of those signals is changing, the effect is re-executed. It's executed once in the beginning, and every time one of the signal is changing, it's re-executed. Okay, let's have a look to this. Paris, so let's say we want to go to San Francisco, yeah, you see, we now have an reactive system. Or New York, what's with New York? Yeah, cool. Or with, I don't know, Berlin. No Berlin flights, I'm very sorry. Bremen, yeah, in Germany. Bremen, yeah. So it's indeed Boston, yeah, a reactive system. We don't have any debouncing. Unlike with RxJS, we needed to implement debouncing by hand, or we could add some additional library like RxJS. I will come back to this in some minutes when we talk about the interop between RxJS and Signals. Both work really nicely together. Before we do this, let me show you another thing. Let's set up another effect that is writing out the current value of from and the current value of to. Obviously, now after each and every change, we get something printed out of the console. So let's say we want to go to Hamburg. It's a bit too much noise, so let me quickly disable all those additional log statements. It's destroying my karma. In my case, it's an interceptor. Should be better. So let's go to Hamburg to visit my good old friend Dave. And yeah, you see, every time I'm typing in something, we get the current values print out here. A, B, C, D, A, F, G. Yeah, here we go. It's print out here. Now let's do something interesting. Let's move back to our component and let's call set timeout. After some seconds, let's say after 2 seconds, I want to change my route. I want to change from to Vienna and to Hamburg. And look here, we really see that it changed from Paris to London to Vienna, Hamburg. This is what we would have expected, isn't it? However, if we think a bit more about this very case, we find out that something special was going on here. Namely, after setting from to Vienna, we would have an intermediate state. An intermediate state, or as the official term here is a glitch. A glitch that tells us, hey, the current route is Vienna to, what was it before? London. Yeah, London was my default value for do. We would get this for some milliseconds. However, obviously in this case, we did not get this glitch. We just have Paris, London, and Vienna, Hamburg. There was no glitch. This is one of the guarantees Signals give you. Signals are, as they call it, glitch-free, which is the official term, by the way. If we went with RxJS, we would have a very different situation. In RxJS, we would have got this glitch. And this is fine. From RxJS as perspective, it's really fine. Because in RxJS, when we talk about observables, everything is about events. And indeed, in this case, we have 2 events here. One setting from, one setting to. So having this glitch in the world of RxJS is kind of expected. In the world of Signals, it's not expected because Signals are not about events. They are not suited for be used for modeling events. One reason is they always have a default value. Signals are more suited to model a variable, a value that can change, a value where we want to be notified after it was changed. And that's why it's implemented in a glitch-free way. The algorithm they are using for this is called the push-pull algorithm. You can find more details about this algorithm in the official docs. Also in my blog article about signals, I'm linking the official docs of the Angular team where this very algorithm is described. To say it, or to put it in a nutshell, this algorithm is first of all updating the values, and then in the next stack frame, the consumers try to find out if they need to be updated. That's why it's called push-pull. We push down the new value and the consumer just do a little tiny check to find out if something happened for them. This happens in 2 stack frames. And so, yeah, it is not intermingled. We can first of all update the values, and then we get the updated values in our consumers, which in our case is the template itself. Okay, cool. Nice property of signals. So perhaps before I'm going on, we could further improve our application, because the current trend in the world of Angular is about improving all the things, isn't it? Just think about standalone component. It is improving, but also simplifying everything. Think about all those little tiny updates we've got, like data binding router variables to inputs. It's also about simplification. So we could also try to simplify this method here by switching back to promises. Then we would have one less place where we go with RxJS. So for this, let me go in here to my service and let me wrap up my find method into a method called find promise. In this case, I'm returning a promise. The whole method is delegating to the traditional find method from to urgent. And the result, an observable, is converted to a promise using first value from or last value from. It's really up to you. Okay, cool. Let's go with find promise. Let's go with await and async. And now let's set the flight. Perhaps it's a bit a matter of personal preferences. However, I really enjoy using async and await nowadays, especially in cases where I don't need the power and hence the complexity of RxJS. In this case, just get your value and set it. Of course, if you need the power of RxJS, all the operators, the possibility of canceling your request, then RxJS is the way to go. If this is not the case, perhaps we should keep it simple. Let's double check if this still works. No, I think there are no flights from Vienna to Hamburg. So with Graz, yeah, here we go. Yes. Okay, cool. This brings us to the next big topic, namely the RxJS and NGRX interop with signals. I just told you, if you don't need the power of RxJS, you can just leave it away. However, sometimes you need the power of it, of its operators and so on. And in those cases, it's really good to know that there is a bridge between signals and RxJS. You can nicely combine both of them. For this, the Angular team gave us this namespace, Angular core Rx interop, and this namespace has 3 functions. The first function is converting a signal to an observable. The other function is doing the other way around. It converts an observable to a signal. And then we have this convenience function called take until destroyed for implementing the until destroyed pattern for closing observables. I'm going to use it in a minute, or perhaps in 2 or 3. Okay, let's have a look at this. Here, I'm going to convert from and to observables because I want to debounce them. Let's do it step by step. I'm starting with from dollar and I'm calling to observable and I'm passing in this dot from. So to observable is not auto imported, so let's import it by hand. Import stuff from Angular for RxJS interop. And here I'm going with to observable. I'm also importing the other 2 functions, namely to signal and take until destroyed. But we will start with to observable. Okay, cool. Let's do the same with to. And then let's go on with combine latest. I'm creating another observable calling criteria color. And here I'm using the power of RxJS. I'm combining from and to. I'm using the syntax with the object. I'm setting up a pipe. First of all, I want to filter everything. I'm saying, hey, let's start with the combination of from and to, and let's make sure that the length of from is greater or equal 3. And the length of to is also greater or equal 3. And if this is the case, let's proceed with the bounce time and 300 millis. And of course, I could now go with criteria dollar. I could directly use it. I could subscribe to it or use it in any other possible way. However, to showcase the other way around, to convert from an observable back to a signal, I will create a criteria signal and I'm going with to signal. Okay, let's pass in this dot criteria dollar. And if we now look at the result of all of this, we see it's a signal containing an object with from and to, or it also could be undefined. Why undefined? Well, the thing is, a signal always has a value. It comes to life with an initial value, always. However, an observable does not need to always have a value. It does not need to have an initial value. And so in the case of cases, toSignal is just assigning the value undefined as the default value, as the initial value to this newly created signal. If you don't want to have something like this, you could set up an initial value here. Could say, well, I have from and to. And then the value is an object with from and to or from and to. Yeah. So I think at the end of the day, it's from and to. Okay, this is one possibility. Another possibility to achieve the same is to tell toSignal, hey, toSignal, trust me, I'm an expert. I have an observable that is immediately, synchronously emitting a value. However, in this case, you needed to go with something like start ref, or perhaps you have a subject with a default value as the basis of your observable. So those are the two possibilities. I'm sticking with the former one. Okay, cool. So now we have this signal that has a debounced and filtered value of from and to. And now we might use this criteria signal inside of search. So let's unwrap the two values from to, streamline this a bit. Let's check for from. Let's check for to. And that's it. So the good message is now this effect here will also subscribe to criteria and always trigger, always re-execute its function when it changes. Let's try it out. Debouncing, let's try it again. I want to go via Graz. Debouncing, yeah, it works. Let's say I want to start in the city of L. L does not work. It's filtered because it's less than 3 characters. Okay, 3 characters would have been enough, but 2 characters are too less. 3 characters are fine. So it's now filtered and debounced, obviously. Nice, isn't it? There is another nice characteristic when it comes to signals. Namely, signals or consumers of signals are automatically unsubscribed. We don't need to remember that we need to unsubscribe something. No, unsubscription happens automatically. To prove this, let me do something crazy. Where is my criteria? Here it is. We have from and to. Let me also pass in a dummy value that is just the result of an interval. An interval that gives us a new value every second. Let's go with a start value here, dummy, start value -1. And let's create another effect here. That is just writing out this dummy value, our counter. Is dot criteria dot dummy. Okay, cool. So we see JavaScript is counting up. JavaScript is really good with counting. However, if we navigate away, check, the counter stops. And this really shows that a signal is unsubscribed by default. Or to be more precise, a subscription to a signal is unsubscribed, disposed by default. We don't need to do anything. It's automatically bound to the current building block, to the current component, for instance, or the current service or the current pipe. It is aligned with the lifetime of this very building block. Quite nice, isn't it? Well, let's do another experiment let's directly subscribe to criteria dollar, because it seems like that criteria dollar is created upon values that come from signals. Criteria dollar. So now we should see that we have the counter again. Yeah, it's counting up. JavaScript is so good at counting. And if we move away, criteria dollar is still in place. It's still counting. This is the default behavior we know from observables. And even though we go with stuff like do signal or do observable, this default behavior is not changed in the case of observables. This would be too confusing. So here, as always, we need to unsubscribe by hand. And for this, we could go with a pipe that is implementing the good old destroy pattern, take until destroyed, yeah? Or I'm just going with this convenience function. Where is it? Where is it? Yeah, here it is. And this will do the same for us. It is using the same mechanism signals use to bind consumers to the current context or the current building block. The same happens here. And when the current building block reaches the end of his or its lifetime, then this will emit a value. Okay, it's counting up again. And if we move away, hey, everything is fine. How cool is that? Okay. Talking about effects, there are two things you should know about effects. There are two restrictions. One restriction is an effect has to be called within an injection context, which is most of the times the constructor or the default value of a property. Saying this, if you try to start an effect somewhere else, for instance, within Ension init, we will get an exception at runtime. Let's try it out. Bang, we get an exception at runtime telling us that effect can only be called within an injection context. There is a new helper method, by the way, that helps you to set up a new injection context. However, you need to pass in your very injector, the current injector. So let's try this out. Let's get hold of the current injector. Let's inject the injector. Now let's run this guy here. And let's pass in the injector. What's going on? Oh yeah, it's the other way around. First of all, we have to pass in the injector and then the lambda. And this would work. However, if you ask me, in most of the cases, just going with the constructor is good enough. Yeah. No error anymore. You can even streamline this a bit by directly passing the injector to the effect function. Injector this dot injector. In this case, the effect function can set up its own injection context. no error message. However, I guess in most of the cases, as mentioned, just going with the constructor is fine. There is another limitation you should know about effects, because otherwise you will run quite quickly into issues when you try all of this out. Namely, an effect is not allowed to write into signals. So if I would do something like this here, I would say, well, every time from changes, I want to update 2 to the same value because I want to sell some round trips, then this will fail by default. You see it here, writing to signals is not allowed in computed or effect by default, and it tells us to use allow signal writes, for instance, which is just a flag we can set to allow writing into signals. So the big question here is, why is the Angular team not allowing this? Well, it should act as some kind of child-safe facility, because with something like this, you can really easily shoot yourself into your leg. Especially if you do something like this, this would end up into an infinite loop. And you don't want to have an infinite loop. That's why by default, we get this limitation. However, if you really know that everything you are doing is fine, well, you could set this property to true. And then the child safe facility is disabled. But that means now you are on your own. Now you need to take the responsibilities for actions you do in there. It works here, Vienna. It works in this case. It's not critical, it's not a loop, it's not a cycle, but it could be a cycle, or it could be evolved to a cycle if someone is changing the source code. Okay, those are the 2 limitations I wanted to inform you about. So now let's go on. Let's talk a bit about state management. And for this, I'm starting with a simple option for state management, namely with a self-made store. A very simple self-made store, the equivalent to what we called signals with subjects in the past. No, not signals, services with subjects in the past. Instead of services with subjects, we could now go with services with signals. For this, let me check in everything I did here. I will send out it to you afterwards. Live coding. And now let's switch over to the example I've prepared for you. It's this example here. We still have the flight search component, but now the flight search component is using a flight booking facade. And all the signals are taken from there, from do and so on and so forth. The facade, of course, could use a simple store like the component store, NGRX, or the upcoming NGRX signal store. But in this case, I'm on purpose just reducing myself to things that ship with Angular. I'm just setting up a private state signal. Private state signal. It's just one signal with all the state I want to manage inside of this service. I call it facade, but you might call it somehow else. Store or service, it's up to you. The thing is, this here is private because the state is writable. Signal always gives us a writable signal. However, normally, I don't want my consumers to directly write into my state. I want to give them a read-only representation of parts of my state, and then I want to provide some methods that update the state in a well-defined way. And this is what I'm doing here. I'm using computed. Funnily, computed works a lot like selectors in all the store implementations out there, like NShareX, NShareX Component Store, and so on. Here I'm just saying, well, please give me flights, or give me from, or give me to. And when I want to update something, well, then I'm just calling my helper function batch signal to batch my changes into the current state here. In this case, from and to are batched in. And for this, I'm just going with the update function we've seen before. The current state is merged together with a partial state. I'm passing a partial state like just from and to. So here I'm really just going with things that are part of Angular itself. We could improve this implementation a bit by passing in an equal function. The equal function tells the signal if the value has changed after an update. Just to give you a simple example, if I update a signal with the value 5 by setting the value 5, this is not really an update, isn't it? And in this case, already the default implementation of equal will say, well, I'm just doing nothing, because obviously the value has not been changed. Doing the same for arrays and objects is a bit more difficult, because doing a deep comparison is not doable for performance reasons. However, if we assume that we go with immutables, then doing the same for arrays and objects is very easy, because then we just need to compare the object reference, and this is what my implementation of equal is doing here. It is just comparing values for primitive variables and the object references for objects, including arrays. So if you want to improve your performance when going with immutables, then make sure you pass in an equal function like this. We could further improve all of this a bit by having a separate signal for everything on the root level. Normally, going with equal should be good enough, but to get a bit more performance out of it, having a separate signal could be beneficial. This is also something the NShareX team plans for the new signal store. Currently, there is a CFP, but in the next months, we will get a complete new, simple NShareX signal store that takes care of all of this. And the usage of it will be quite similar to what I'm going with here, but it will be a bit more powerful, obviously. So check it out. Okay, so what if you already have NShareX today, or if you want to go with NShareX, the component store or the traditional store? Well, I also have an example for this here. The good message is we don't need much for the store to work with signals. More or less everything we need, at least at the public API surface, is a new method called select signal. Select gives you obviously an observable. Select signal does the same. It takes a selector and returns a signal. And that's it. The rest is the same. So switching over to signals is really a piece of cake. And I think this is really a huge value of Angular. Angular innovates. Yeah, Angular is innovated on a current basis and on a regular basis. However, the innovations always happen in a backwards compatible way. a way that is not breaking your stuff. You can just use your existing code. You can use your existing patterns you have learned, you have in your head. And sometimes you have a new function you have to call. This is the Angular way of evolving a huge framework. I really love it. By the way, we had the same with standalone components. We had the same with Ivy. We had the same with all the other little tiny updates that make Angular more lightweight. Okay, let me sum up what we have seen today. No, before we are summing up, let's have an outlook to the future. Because the future, sometime after Angular 16, we will get signal components, which is a new kind of component. The idea is, this is taking out of the current RFC, the idea is to provide a signals flag we set to true. So this is similar to standalone components. And then we have this new kind of signal components that is only using signals for change detection. Everything is a signal here. Of course, the properties are signals, computed properties are signals, but also inputs will be signals. And by the way, here you already see for setting up an input, a property, we don't go with decorators anymore. The idea is to make decorators optional in the future. Instead, we just go with this function here, input. Interestingly, at least according to the current RFC, regardless if the consumer puts in this value as a signal or not, it shows up in here as a signal, so we can use it in a reactive way. So what is the benefit of all of this? Well, one benefit is this will work completely without Zone.js. Plus, it gives us the opportunity to clean up the API a bit. As mentioned before, one goal is to make decorators optional. However, it will still work with traditional components. You don't need to worry and hurry. Everything you have written so far with Angular will still work in the future. You don't need to update it. Both works together, the new world and the existing world. However, in this interop scenario, obviously you still need Zone.js. However, if you start a new application, you can, in the future, sometimes in the future, leave Zone.js away. And this is really cool. This also gives us a more fine-grained change detection. Traditional components are always checked as a whole, and even in on-push mode, all the parent components are checked for changes. Because the traditional change detection always goes top-down. It follows the paths of 30 components, so all the parents need to be also marked for check, as it's called. However, this is not the case with signal components anymore. With signal components, it's possible to just update a portion of your component, a fragment of your component. If something just changes in the bottom right corner, only this part of the component is updated. It's really more direct and more fine-grained. This little tiny portion that can be updated, by the way, will very likely be an embedded view. An embedded view is, for instance, what you get when using a structural directive like ngIf and ngFor. The Angular team don't want to go down to the binding level because there would be some overhead if they went down to the binding level and if they updated everything on a per binding basis. That's why they decided for something in between the whole component and the binding, namely an embedded view. That means every time you do a loop or an if or a switch, you get for those parts a separate data binding, to say it quite frankly. And if you say, well, this should be updated alone, then you could just wrap it into something with a structural directive. Perhaps someone gives us something like Angie let or Angie updates this in isolation. And as mentioned before, no need to update your code. Everything will still work. This is really cool. Everything is backwards compatible. However, obviously, if you start with a new project, it would be smart to start with the new way of using Angular. And now it's time for a conclusion. What did we see today? Well, we saw that all of this gives us a fine-grained change detection eventually in the future, once signal components land. This paves the way for a zoneless future. We can still use observables. If you love RxJS and or you need the power of RxJS, you can nicely combine signals with them. There is no need to unsubscribe. I really love this because I'm quite a clumsy person. I always forget to unsubscribe. No need for unsubscribing. The lifetime of a subscription to a signal is bound to the current building block. And no need to update code. We have the usual guarantees the Angular team normally gives us. They really take care of us and our source code. I'm very thankful for this. By the way, saying this, signals are currently with Angular 16 in developer preview. That means you can try it out. And I think they will become publicly available in one of the next versions, hopefully with Angular 17. Hopefully. And before we start with the Q&A, I'm sure you have a lot of questions. I want to show you something else. Namely, if you want to learn more about all of this, if you want to learn how signals will influence your architecture, and if you want to learn about other things for building a huge enterprise scale application, then this workshop might be interesting for you. It's about maintainable architectures for enterprise scale applications. We completely updated it to standalone components and standalone APIs. We cover micro front ends and module federation. And we also cover signals and all the goodness around signals. We even combine it with a store like NGRX. It's available as a public workshop or as a company training, remote or on-site. Here we have the link to the German version. Here we have the link to the English version. And talking about the English version, the next English installment happens quite soon, next month. So yeah, feel free to go to this page to have a look at the agenda. If you already miss me after this webinar, here you have a picture of my lesser self. And then click here to book now to get your ticket. By the way, we also have group discounts if you want to join with your colleagues. So check this out. And with this now, we can move over to the Q&A session. Oh, a lot of comments. Wow. Over 200 comments. That's really awesome. I did not expect this. So let me look. Hello. Hi there. Yeah. So where do we have the questions? Why should we implement from and to as signals? Well, the reason is currently you can, of course, stick with immutables and observables. But if you want to switch over to the new world, and if you want to data bind from and to, you would model them as a signal. Currently, it does not matter that much, but eventually, when it's about this new style of Angular, everything that is data bound will be a signal. Yeah, and in our case, also someone said it, we directly reacted upon a change of from and to. Yeah, also because of computed, of course. Yeah, someone is already suggesting that this might pave the way to a zoneless future, and you are right. Yeah, this is what I came for, blinking problems. Yeah, but in this case, it's not a bug, it was a feature for tactical reasons, of course. Yeah, and currently, with traditional components, uh, just reading from a signal in the template is more or less the same like reading from an observable with the async pipe. More or less the same. There are little tiny differences underneath the hoods, but you don't need to concentrate on them. Yeah, you also can go with this good old as and she if unwrap scenario. Or you could implement an Anshi let. I really think this is my prediction for the future. I really think sooner or later we will get something like Anshi let, something that allows to tell Angular, please update this part of the signal component in isolation separately. Yeah. On-push signals and immutables. Yeah, this is the way to go. And the good message is if you are already using Anshare X, you don't need to change much. You can even stick with most of your current thinking and patterns you're using. Yeah. Yeah, good question. What's the difference between this and using an observable? So from the runtime perspective, currently it's about the same. This will change with signal components where we get this more fine-grained change detection plus an option for working in a zoneless way. However, currently it's more or less the same. However, if you don't need observables, then you could just go with signals, which is by intention a simpler building block. By intention, it's a simpler building block compared to observables. Saying this, it's not that powerful. However, it's good enough for, let's say, 90% of the applications out there or the use cases out there. Especially if you write business software, CRUD-based applications. But yeah, technically, currently, it's about the same. This will change with signal components. Yeah, indeed, the async pipe needs Zone.js currently because someone needs to tell the async pipe, hey, do your job. There is a replacement for the async pipe. It's called the push pipe. It ships with NGRX, and it does the same without Zone.js. But it's not an official feature of Angular. Yeah, I really would say it's a bit more readable. You're not forced into observables, however, you can use them if you need or love them, or both. Yeah, so one more time, why signals? We already have observables. The idea was indeed to provide the community with a simple building block because not everyone should be forced into using observables. For some cases, it might be too complicated and not necessary. Yeah, you don't need to forcefully migrate observables to signals. I would do it once we have signal components for newly written source code. Yeah, we still have not seen how signals help with big applications, but yeah, the Angular team is working on this for quite a time, so I'm quite sure it will work nicely. Also, signals is not a new idea. We have very famous and well working implementations in other frameworks. First and foremost, Solid. Yeah. Signals is currently in developer preview. Let's emphasize this. That means you can play around with it and it will be ready for prime time. Hopefully, this is my personal hope. I don't have any official information with Angular 17. Yeah, lots of interesting statements and questions. Yeah, some people are a bit reluctant of using signals. That's fine for the time being. Bum 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 bum. Let's go down. There was a huge discussion. Okay, that's why we have so many entries. Let me look for the next question mark. Bum 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 bum. Okay, so seems like signals are creating a lot of emotions when I'm looking into the chat here. And yeah, it's a change, and that's why it's normal that a lot of emotions are involved. That's part of the game. And that's why the Angular team is doing this transition, I'm repeating myself, in a very careful way. Everything is compatible and so on. That's an interesting question. Are signals only for components? You can use them everywhere. You can really use them everywhere. In components, in pipes, in services, in directives, in good old objects and classes, everywhere. This was how they have been designed. However, things like the effect need an injection context. But the signal itself can live everywhere, can be maintained everywhere. No, there is no debounce for effects, but you can use Lodash or convert over to observables. I would do the later one because NGRX is still part of Angular, so it's still in there. Why not use it? How are they destroyed in services? Well, the thing is, on a logical level, um, the subscription to a signal is always bound to the lifetime of the current building block, to the lifetime of the service, to the lifetime of the component, and so on. If the service is a global one, then the service is never destroyed, and then also the signal lives forever. However, if the service is a global one, you very likely want to have something like this. It was the same with observables. If you had a global service, a for root service, and if this service provided an observable, you wanted it to live for the lifetime of the application, very likely. If the service is registered with a component, then the lifetime of the service is synchronized with the lifetime of the component. And this means that also the signal used in there is synchronized with the lifetime of the component. Yeah, this is how it works on the logical level. On the implementation level, there is just a service you can inject, and this service tells you when the current building block is about to die, and you can register a callback for this. It's the so-called destroy ref. Quite a nice idea. It's simple and very effective. I'm wondering why we did not come up with something like this earlier. Yeah, also take until destroyed is using this destroy ref underneath the hoods. Yeah, discussions, blah, blah, blah. So we don't need NShareX anymore. Yeah. No, I would not put it this way. I would not put it that way. So if you need global state management, then I think NShareX is still the way to go. If you are fine with a more simple store, like the component store or the signal store, or something like services with signals, you can also use those approaches. In this sense, the world is not really changing because we had this situation from the beginning. Some people go with NShareX, with global state. Some people go with something more lightweight. Some people just go with services and reactive building blocks. More or less, we have the same possibilities. The good message is the NShareX store, the component store, now also support signals. Question mark. Yeah, this is also a nice observation. Going with an input signal and having an effect for it is about the same as going with ng on init and or ng on changes. Yeah, that's right. Of course, you need to respect that writing into signals from within an effect is not allowed by default. And you should keep in mind that going with computed whenever meaningfully possible is also a good thing. Okay, we are coming to the end here. Signals work with reactive forms. Yeah, they work with reactive forms because reactive forms are more or less decoupled from the source, from the data source. So it works quite nicely. It also works with template-driven forms. In this case, you just have to use ng-model in this explicit way I've shown you so far. So let's see what the Angular team is coming up with in the future. One thing is for sure, the Angular team needs to renovate the forms module, because meanwhile we have standalone stuff and we have signals. So perhaps now it's the perfect time to renovate Angular forms. But the Angular team is aware of this and they will come up with a nice solution. Can we share signals between micro frontends in the same way as observables? Yeah, technically it's possible. However, we should keep in mind that signals are not for modeling events. So if I want to share an event, I would still go with an observable. But if you want to share state, hopefully not too much, if we talk about micro frontends, then this is really fine. Yeah, so thanks for all the compliments. I also enjoyed it. Of course. Now I know why I know you, Timo, because the picture somehow looked familiar to me. Now I know why we know each other. Yeah, let's talk at Ender.js, of course. It's in 3 weeks in Darmstadt, in Germany. Well, my wish for Santa Claus is that we get signals as a ready for production version, as a production ready version with Angular 17. And I really hope that with Angular 18 we have signal-based components. But those are just my wishes. I really hope for it, but I don't have any official information. Well, I think Zone.js will be a part of Angular for quite a long time, because we want to have it backwards compatible. This is one of the goals. However, sooner or later, even though it's a part of Angular, you can skip it, especially if we go with new applications just using standalone or just using signal components. So what do we have else? I'm not aware of a planned feature for this here. Yeah, if you already have an existing application and if you really want to migrate it to Signals, Signal can really help you. Yeah, but you don't need to worry and hurry. You can leave the existing code as is and just use Signals for new code. But of course, if you want to move over to the latest and greatest features, yeah, then Signal will help you. The code will be on GitHub. Yeah, I will send it out and I will link it here underneath the recording. Okay, cool. I think that's it. So thanks for joining us. It was really a pleasure for me to talk about signals. And yeah, let's keep in touch. Follow me on Twitter, plus check out our workshop that happens the next time in some weeks, our public, remote, interactive Angular architecture workshop. Okay, thanks and have a nice day. Bye-bye.